If you're totally new to SHACL, this is exactly the kind of intro I wish I had when I started. Think of this as a friendly, beginner-friendly mini-series. By the end of this first video, you'll not only know what SHACL is, but you'll also walk through a simple example and validate real data in a triple store. Hands-on, easy to follow, and no unnecessary fluff. All right, let's get started. Open VS Code and make sure you have an RDF syntax highlighting plugin. For example, the one from Stardog, so the files look clearer and easier to read. We'll create a very small SHACL example together, bring it into GraphDB, and validate it as it loads. You only need a little bit of RDF knowledge, but don't worry, I'll keep everything simple and friendly. Our rule for today is straightforward. If something is a Pokemon, it must have exactly one Pokédex number, and that value has to be an integer. If the rule isn't met, the data is blocked from entering the triple store. We'll start like any RDF file by declaring a few prefixes. SHACL terms are with the SH prefix. First, we create something called node shape, basically a checklist for nodes, and we name it Pokemon shape so it's clear to human eye that it belongs to the Pokemon class. We tell SHACL where it refers or who to check using the built-in SH target class. Think of it as apply this checklist to every node of type Pokemon. Next, we attach a property shape to that node shape. We can name it whatever we like. Let's use Pokédex number shape. This rule is about Pokédex number and what it must look like. So right after, we define what exactly is that property shape we just named. As you know, A is shorthand for RDF type. Property shape is built in SHACL and means rules about one specific property. And we end with the semicolon, which means more details are coming in the next lines. So next is path Pokédex number, saying which property the rule is about. Think of SH path as a point to the property I want to check. Here it's a simple property. In the next videos of these series, we will use more complex paths. Data type integer. This says every value of Pokédex number must be a literal typed as integer. In plain words, it must be a whole number, like for example 25. No strings, no decimals. Some tools show numbers nicely, but under the hood, SHACL checks the data type. Next line, min count 1, like there must be at least one Pokédex number. This makes the property required. No number? That's a violation. There also must be at most one Pokédex number, so max count 1. Two numbers, also a violation. Together, min 1 and max 1 means exactly one value. Think of it like a tidy queue. One ticket, one person. Finally, a human-friendly error message shown when validation fails. ESH message, for example, a Pokemon needs exactly one Pokédex number. Integer. It doesn't enforce rules, it just explains them nicely to us when something goes wrong. The period dot ends the shape definition. So now let's use it. But how? Do we import it in the triple store like ordinary data? Okay, think of a SHACL file as just another RDF file. It's an RDF graph that uses the SHACL vocabulary, the terms with the SH prefix. Conceptually, it's still RDF, it's just stored where the validator expects it. So mostly, yes, we import it in the triple store like ordinary data. But many systems keep shapes in a special named graph so the engine knows these triples are shapes. As I said in the beginning, we will use OntoText GraphDB, which likes it when we import shapes in a specific named graph. Think of it like two neat buckets. One shape's bucket, where the rules live, and your data bucket. When we import a SHACL shapes TTL, we drop it into the SHACL shapes graph. So GraphDB knows, these are rules. Then whenever we import or update data, GraphDB does two things in order. It runs its reasoner to add any inferred facts, and then it validates that materialized result against our shapes. That order matters. You catch issues that only appear after inference. If you're not on GraphDB, the big picture is the same. Write shapes, import data, read the report. Clean separation, predictable behavior, and you get fast feedback right where your data lives. Anyway, now, the first step is to download the triple store. It's straightforward, but if you get stuck, feel free to reach out. The important thing here is that when you start a new repository, you have to tick the respective box. If you forget that, none of the validation will actually run. Don't skip it. So finally, to the action, go to import, then text snippet. Copy and paste the file we created earlier. You also have other options, like uploading a file or using Python, but let's keep it this way for now. Then select Target Graph and set the named graph to the one GraphDB expects it, and we saw earlier in the documentation. That tells the triple store these triples are shapes. A quick note here. When I say shapes, I mean SHACL shapes. It's literally the same thing. Okay, let's see what we actually did. The default graph is empty for now, no change in the total statements. Why? Because the shapes are stored as triples in the named graph we specified earlier. You can see here the bits like path, max count, and message. All the rule stuff saved as triples. Now peek at the default graph so you don't think I'm making this up. 0 data. This is where our real stuff will show up once we ingest it, and it'll only stick around if it passes validation. No pass, no entry. The bouncer says nope. All right, now let's jump back to VS Code and grab this Pikachu and Bulbasaur example. Each one has a nice little integer Pokédex number, so it should pass. Paste it in as a text snippet, hit import, all green. Let's peek at the default graph. There they are, our little Pokemons hanging out. And hey, let's even visualize Bulbasaur. Looks perfect. Both pass the rule, both safely living inside the graph now. Okay, trouble time. Let's grab the Mew example. It's missing the number. You can see that. Import it again and validation failed. All right, scroll past the prefixes. Here's the report. C conforms, false, not okay, something broke. Then you get the results list. Each one is a specific violation. Now the juicy bit, focus node, who failed? Yep, Mew. Shapes graph, which graph the rule came from? Our shapes bucket. Result path, which property is the problem? Source constraint component, which kind of rule? Min count constraint component equals you're missing at least one value. Result severity, violation, hard fail, not just a warning. Result message, the friendly text we wrote earlier, be nice to yourself in future. Source shape, the exact shape that enforced it. Pokédex number shape. So basically it says, for Pokédex number, there must be at least one value. You didn't give it one. Boom, door closed. All right, finale time for part 1. Let's throw all 3 troublemakers in and hit import. We've got missing number, number is string, and way too many numbers. Result? Nope, not imported. Scroll past the prefixes, and here we are. 3 violations. Mew, min count. No number, classic. Eevee, max count. 2 numbers, greedy floof. Charmander, data type, constraint. 4 as a string, not an integer. And that's it for round 1. We wrote our first little shape. Not bad, huh? So we stop here for this video. In the next part, we'll make the rules a bit more spicy, things like enums, only certain values allowed, or object properties. We will see. If you followed along, congrats. You've already got SHACL running in GraphDB. Now go break some data on purpose, play around with it, and see the errors for yourself, trying each time to follow the shapes everywhere. Trust me, it sticks way better that way. See you in the next one.